Do you know if there's many more we're waiting for, Ragaraj?
I think this is good. We can start. We're already 3 minutes in, so it's a good time to start.
Okay, excellent, cool. Let me turn my video on so you can see me. Okay, so hi everyone. My name's Tom Moore. I'm a solution architect here at AWS, and today I'm going to talk to you about the AWS global infrastructure. So essentially, we're going to talk about how we scale, how we deliver the cloud globally at AWS, how we provide the kind of secure, extensible, and reliable infrastructure for our 200 fully featured services globally. But before we do that, a little bit about me. This is actually a photo from my badge. I don't always look this miserable. But yeah, my name is Tom Moore, or I always write my name as Thomas, but happy for everyone to call me Tom. As I say, I'm a solution architect. So what does that mean? I'm essentially I work with customers, so it's a customer-facing role. But I'm here from a technical point of view. So I help our customers with architectural guidance, best practices on running services and building their applications on AWS. And I also organize things like workshops to help customers understand and learn about our services that we offer. I'm actually based in the UK, in London, so it's the afternoon for me, and I work in a team called the ISV team. So this means that I work with independent software vendors, people who write and produce and sell their own software. And those customers we tend to find are also partners with AWS because we sell with them. Um, a lot of those customers that I work with are building SaaS solutions on AWS, so software as a service solutions that they then deliver to their own customers. A little bit about me then. I studied computer science at university, and really I got into the tech world when I was growing up. My parents bought our first family computer and had absolutely no idea how to use it. I was quite inquisitive as a child, so I spent many hours learning, how it all works from a software and hardware point of view, and that kind of sparked my tech career from there. And I've kind of been helping people understand and use technology ever since, really. So yeah, I probably have about 10 plus years of experience working in industry, both with on-premise and cloud technology from an infrastructure point of view. I'm also owner of a cat. I have a British short hair who's had a number of injuries over the last couple of years, and also enjoy traveling when we can, enjoy Formula One, and playing guitar. So just a little bit sort of a pivotal point in my career, I guess, or some piece of advice that I was given early on was that if you don't enjoy the journey, it's not necessarily the right career for you. It's not necessarily saying give up, but I think it's something that stuck with me because, you know, when you start out, you're often involved in the boring bits, right? So when I started in my tech career, I ended up doing data entry, changing some backup tapes, and I really enjoyed those bits because I took it as an opportunity to learn from experts. Um, you know, do the job, do it well, and then I just managed to kind of find my feet from there and find ways to optimize the process and make it better with automation and learn bits around that. So that's me. We're going to go and dive into the global infrastructure. I should say that at this point, if you have any questions throughout the presentation, then just jump in and ask. I can't actually see the chat window in front of me. I'll take chat questions at the end. But if you have anything that you want to call out, then please come off mute and say and ask. This session is for you guys. It's not for me. So I want to make sure that you understand anything, any questions that you have related or unrelated to the presentation, then please ask. But we should have enough time at the end for Q&A as well. So we're going to talk about the global infrastructure. We have millions of active customers across the globe. Every industry, every size, from startup, enterprise, public sector. What we're going to talk about today is how we deliver these things called regions, what makes up a region, how regions are connected from a network point of view, and some of the hardware that we have in these regions. So before we go back to this kind of map view, first want to just cover why people choose to use the cloud and why people, why cloud infrastructure has become a big thing. So the kind of main benefits are that we can increase the IT agility and performance. So a lot of customers are in competitive industries. They need to accelerate, they need to grow, they need to change rapidly to external factors. The cloud gives them this ability because they no longer have to plan for IT expansion. So expanding physical space in a data center, racking and stacking IT equipment, and powering and cooling all of that. If you think about the global pandemic with COVID-19, we've all been affected by that. It's really been a really big impact for lots of companies in terms of IT. Those that are using the cloud can scale up and down. So some industries, for example, hospitality, they needed to scale in quite quickly in order to save some money, whereas other industries such as Netflix, saw a massive boom with new customers, people streaming new TV shows from their homes as they were locked in. They needed to expand out quite rapidly. So having that scalability is one of the benefits of using the cloud. Improve reliability as well. So if you think about operating your own hardware and your own data centers, you need to think about things like redundancy. Are we going to have multiple physical sites? Are they going to be connected to different power sources? How are we going to handle accidents? I've experienced myself where someone's pressed the emergency stop button in the data center and powered the whole thing down. How do we deal with accidents like that? Well, the cloud is kind of built with these things in mind, so we can improve the reliability of our applications through doing that. And then ultimately, we want to lower costs as well, right? This is key to every business. Everyone building solutions wants them to be as cheap as possible. Someone operating at a global scale like AWS can take advantage of economies of scale when they buy hardware. When we buy hardware, we can buy it at a much cheaper rate. And we also have innovations such as our own custom hardware, our own custom software that we write to make the most efficient use out of those resources. When we get those efficiencies and savings, we then pass those savings on to our customers. They can save on their IT spend and then pass those savings on to their end customers as well. So we need to build out a global network in order to reach all of our customers and be able to offer the cloud to everyone around the globe. So what are the kind of key things that we need to think about when operating a cloud scale network? Security is at the top. AWS security is always job zero, comes above everything else. We need to make sure that everything we build has security in mind, whether it be encryption or access control. Availability. So customers depend on our infrastructure to operate their business. Some of them, very, very critical businesses. We need to ensure that we operate and provide that availability to our customers on the cloud. And we also need to make sure that we constrain and isolate failures that do happen so that they don't spread further than they need to. We'll look at this when we start to look at the different isolation and fault tolerance between the regions. Scalability as well. So we don't want to keep anyone, we don't want to be constrained of growing at any point. We want to keep expanding globally. We want to keep delivering and satisfying our customers in order to enable them to grow and expand. Performance, obviously, we want things to be the best performant that they can, the fastest networks, the fastest compute. But we also need to think about keeping things consistent. So in the event that a failure happens, we keep the performance at a consistent level that customers expect. And then global, we also want to reach customers wherever they are throughout the globe as well. So going back to our map of the world view then, this is obviously like a really, really distant view of our global infrastructure. And on this map, the yellow dots represent what we call regions. So these are the regions that we operate in around the world. The blue lines between those yellow dots are there for the network connections between the regions. And each one of those blue lines represents multiple 100 gigabit per second parallel and diverse connections between those regions and also between our points of presence. And we'll come on to what that means in a bit. So I mentioned an AWS region, but what exactly is a region? It's a geographical area, so it's a discrete geographical area, and it's designed to be completely isolated from the other AWS regions, but also connected to the backbone. So all the regions are interconnected, but a region in itself is a discrete geographical area. So if we translate this into a logical diagram, then looking over here, we've got a region, we've given it a name. In this case, it's US East 1. This region is in the US. It's on the East Coast, and it happens to be the first one, hence the name. So another example would be EU West 1, which is a region closer to me. This is in Europe, it's in the west of Europe, and it's the first region. We also have kind of more friendly names which relate to where the region physically is. In the case of US East 1, it would be North Virginia. So within a region, then, we have what's known as an availability zone, and we have multiple availability zones within the region. So these are essentially a collection of one or more data centers, but each availability zone is fully isolated, which means that they have separate power, separate cooling. They're also far enough apart, separated by miles, kilometers, to ensure that if a disaster was to occur, it would only impact one availability zone and not multiple availability zones. They are also close enough together, these availability zones, which is really important, that we can provide low latency network connections between them. So they effectively operate as one kind of logical site. And this enables us to do things like synchronous replication for database availability, for example. So if we add that to the logical diagram, then we've now drawn in two availability zones into our region, and we've given them a letter. So in this case, we've got US East 1A and US East 1B. Now, in the case of US East 1, there's actually 6 availability zones, A, B, C, D, E, and F, but we give them letters within AWS to denote their name. So I mentioned that within an availability zone, we have one or more data centers. So just remember that an availability zone is not necessarily a single data center. It can be made up of a collection of physical facilities, grouped together into a logical availability zone. And then within that data center, we have our physical racks, which contain our physical servers. And on those physical servers, we run a hypervisor, which we can run virtual machines on, so our EC2 instances. So adding then into the diagram, we've got our EC2 instances. So you'll see that an instance or a virtual machine has to run in a particular availability zone. And it's really important that we architect our application appropriately so that these services, they run across availability zones. So in the event that this availability zone was lost because of a natural disaster, we can't prevent that from happening, a flood, a lightning strike, an earthquake. The end customers or the end users wouldn't notice because the application would continue to run in another availability zone. So going back to the map then, let's have a look at the regional expansion from when AWS started. So AWS was born in 2006. And for the first 5 years, we had 4 regions. So they were North California in the West Coast, North Virginia and the East Coast, which is actually the first region, Ireland and Singapore. So these are the 4 oldest regions in AWS, and you'll often see get services released to them before anyone else. They have to have the most services available because they are one of the older regions. The next 5 years after that, we then launched an additional 7 regions. So expanding out into South America with Sao Paulo, Australia with Sydney, into Japan and Tokyo, and also launched the GovCloud West region. So GovCloud is actually not necessarily for public use. You have to be screened and approved to use it. It complies with US government regulations. Um, it's worth pointing out that regions are generally come about due to customer feedback, and 90% of our roadmap is based on customer feedback. So when we have demands for a region, that generally uh, uh, develops the kind of need for it. So the next 5 years after this, so from 2016 up until today, we've launched an additional 14 regions. So you can see how quickly this is expanding out. Now we have regions in South Africa, Cape Town, Sweden, Montreal in Canada, Paris, and then we have an additional 7 regions which have been announced. So this includes Spain, Switzerland, UAE, Jakarta, Hyderabad, and Melbourne. These regions we've announced. We usually announce them a couple of years before they're launched. I'm sure you can appreciate it takes a while to build a region out, connect it to the AWS backbone network, install all of those availability zones and data centers. So these will come online in the next few years. So this is just a list of all the regions that I just covered, and next to each one of those regions in brackets is the number of availability zones. So you can see majority of regions have 3 availability zones, and this tends to be the standard. So you'll get an A, B, and a C within each region. Some have less, some have 2. Some have more, some have 4, and they go up to as many as 6 for North Virginia. So we're going to have a little look at how we connect the regions, availability zones, and the data centers from a network point of view. So just remember that a region is a geographical distinct location. So like North Virginia or Ireland, within that region we have multiple AZs, availability zones. And then within that availability zone, we have 1 or more data centers with redundant power, networking, and connectivity in separate facilities. So we're providing the highest resilience and redundancy. So as I say, most availability zones, most regions contain 3 availability zones, some as many as 6. But because these availability zones contain 1 or more data centers, so in this case, there's 5 data centers in this diagram, they will have to be interconnected. And we do that with metro fiber. So these are super low latency, high bandwidth links that connect them together. And there's multiple redundant links between them as well to ensure that if one of those cables is broken, then we continue to have connectivity. So then we also have to connect the availability zones to each other. So we've got the links between the data centers within an AZ. So this is an AZ. And then we also connect each availability zone to each other. So you can see that there's 5 availability zones here, and we've got 5 connections. So we've got a connection to each one of those. They're all connected to each other, again, using fully redundant metro fiber, providing high throughput and low latency. So now we've connected the availability zones to each other. How do we connect them to the rest of the world? Well, we have in each region what's known as a transit center. So these are transit centers. So there's 2 transit centers per region. And each availability zone will be connected to both of those transit centers. So again, providing redundancy. And those transit centers will essentially give the region connectivity to the outside world. So it will connect to other regions, but also give us things like internet access as well to connect to the rest of the world. So you can kind of think about this in terms of like a city. The links between the data centers within an AZ are like your back streets, and you have your main roads that go between each availability zones, and then the highways or the motorways that connect out to the transit centres for longer distances. So these are a couple of pictures of the cabling that we use. We develop our own cables, and we have lots of fiber, as I say, that connects between these availability zones and regions. The cable has got this steel core, and then within it there's multiple fiber strands. A lot of cables have around 3,500 strands in a single cable, and each one of those strands can carry 100 gigabit per second of bandwidth. The newer cables actually have up to 7,000 strands, so you can see how these can carry massive amounts of bandwidth. And because they're fiber, they are low latency. We do pay attention as well to when we plan how to roll these cables out so that they're the shortest distances, provide the lowest possible latency that we can. And we also ensure that we have physical separation for redundancy. For longer lengths, so if we're connecting up to transit centers, we also use something called dense wavelength division multiplexing, or DWDM, which means we can get up to 20 terabits per second on a single cable using our current generation hardware. An interesting fact as well, so this cable here, the blue one, is actually used in Australia, where we have another challenge. The blue coating protects it from being eaten from termites. So termites tend to like to eat cables. In Australia, we have to provision special blue coating to stop that from happening. Other challenges that you face in operating a global infrastructure. So this is a picture from one of the US regions in 2019. With a construction company, whilst digging, they hit the cable. I'm sure you've heard of this story before, and it happens all the time, right? With telephony equipment. Obviously, very badly damaged. You can see by the picture, there's not going to be much network traffic flowing across those cables. But what actually happened is we have an optical level failover system that sends like multiple health checks a day through the cable system. And as soon as it saw the fault was beginning, so not when it happened, but as soon as it saw it was beginning, it was able to transfer the signal over to the backup path. And the monitoring system actually only saw 13 packets lost, which is extremely small and effectively invisible to the customer. Once the cables were repaired, which took about a day, this was then brought back online without any impact to the customer. So jumping then back to our map of the world, I've got a few more dots on the screen this time. And instead of representing regions, we're now representing what are called points of presence, or POPs. These are essentially edge locations. So they're used by a service called Amazon CloudFront quite heavily for caching static content. So when you operate a website, for example, we have images, videos, CSS, JavaScript code, which is static. It doesn't change that often. In order to download that closer to the end users, we can cache it at these edge locations. So they're not full regions. They're not offering all the services, but they do have enough to be able to cache content so that we can speed up the delivery of our applications to our users. We currently have 230 plus of these around the globe, and they're deployed in places of high population to ensure the best distribution of our content. The points of presence are used by other services as well. For example, Global Accelerator. So this allows you to have a static IP address which goes into an edge location, meaning that instead of customers connecting over an unreliable internet backbone, they can get into the Amazon network as soon as possible. And I think it's a good point to mention that if I go to the next one, all of these interconnections between the points of presence between our regions, this is Amazon owned network, so we don't rely on third parties. It's an Amazon owned network. We control it, which means that we can provide the best reliability, but we also hardware encrypt any traffic between the regions. So anytime it leaves one of our facilities, traffic is encrypted at the hardware level before it goes onto that fiber network cable. So we also have something called Direct Connect, and this allows customers to connect their own facilities. So if you've got your own data center or office, you can connect in using a service called Direct Connect, which gives you a dedicated network link into the Amazon backbone and therefore into your AWS region or availability zone without going over the internet. You can also connect via a VPN, so you can use a site-to-site VPN to connect in to your resources privately, but the VPN tunnel will go over the normal internet. Direct Connect is like a private dedicated network connection, a physical connection, which goes into one of these Direct Connect locations that we have across the globe. I'm going to talk a little bit about the AWS custom hardware, but just pausing for a minute just in case there are any questions. I'm just checking in the chat as well if there's any questions from anyone so far. Okay. Yeah, feel free to jump in at any point if you do think of something. So AWS custom hardware, the global infrastructure that we offer is built on Amazon's own hardware. So this includes custom built compute servers, storage servers, routers, and silicon. By silicon, I mean processors as well. We build our own processors. By using our own custom hardware, then we can provide higher levels of reliability and also, importantly, a faster pace of innovation. So we're not bound by third parties in order to start innovating and progressing the technology. We have control of that delivery process. So it means that we can start to reduce cost, we can innovate faster on behalf of our customers, and we can run things more efficiently because we can build the hardware with our services that we offer in mind. When we make these efficiencies and cost savings, and we pass those cost savings on to our customers through price reductions. So when we come out with newer version or latest generation EC2 instances, they're often priced lower than the previous generation as a result of innovations that we've managed to gain. So, for example, we have custom routers. These are designed and built by Amazon. The routers are running custom AWS software. This can provide us with the kind of capacity, the mass capacity and bandwidth that we need to operate the global infrastructure. They're also far more reliable, we find, and easier to maintain than third-party created routers. Load balancers as well. So these are key to availability and scalability. So load balancer will distribute traffic between servers. About a decade ago, AWS moved away from traditional load balancers to our own distributed load balancers spread across many hosts. So again, improving reliability and offering at a lower cost. Compute and servers. So I'm going to discuss this in a couple of slides, but we have something called the Nitro system. The Nitro system is a set of hardware and software developed by AWS, again, for running compute loads on servers. And custom software. So all of these hardware devices require custom firmware and software to run. So like hypervisors, for example, we write our own software to do that. Again, we have control. We can bake in the optimal security for running our services. And then finally, silicon. So let's move on to the next slide to discuss the silicon options that we have. So when you provision servers or EC2 machines on AWS, you have a choice of processors. You can use commodity Intel or AMD processors, but we also have the choice of our own processors called Graviton. So Graviton are ARM-based processors. They're not x86, so they do require slightly different operating system architecture to run, but more and more support for ARM is coming into the industry now. Most Linux distributions, and we have our own Linux distribution, by the way, called Amazon Linux or Amazon Linux 2, which you can run EC2 instances on. We first released the first gen Graviton processors in 2018, and they were powering our EC2 A1 instances, offering kind of cost savings and performance benefits over the equivalent general purpose instances from Intel or AMD. And then in May 2020, we made a significant leap forward in terms of performance and the capability. So now we offer these powering what we call the M6G, the T4G, the C6G, the R6G instances. So anytime there's a G, lowercase g at the end of the instance name, it's powered by Graviton 2. And these provide 40% better price performance over the x86 comparable instance. So customers are moving towards Graviton and ARM based just because of the price and performance benefit that you gain there, and because we control the process. We've seen this happen with Apple with the MacBook Airs that they've released it recently. We control the process, we can get better performance, and we can get a better price to our end customers as well. So I did mention the Nitro system. This is kind of a general overarching term for the technology that powers our servers. So it's made up of a number of components. We have the Nitro card. This is essentially like a accelerator card which goes into the back of the server and allows us to connect into Elastic Block Store, EBS. So this is like a network storage service that connects to EC2. And most recently, we launched the EC2 Mac instances. So we're the first cloud provider to provide Mac OS in the cloud. So people can develop iOS apps or Mac applications. We actually use the Mac Mini devices. So we actually put raw Mac Minis into racks, but we fix them with a Nitro card to allow them to get hardware accelerated performance to connect them to our EBS storage solution. The Nitro security chip, this is something that's integrated into the motherboard, protects the hardware resources. It does hardware level security so that we can ensure that customers who are running on shared hardware get the best level isolation possible. And then we have the Nitro hypervisor. So this is the software hypervisor that we run. We used to use a modified version of Zen, but more recently we moved to the Nitro hypervisor. It's much more lightweight. We can get bare metal-like performance. So the performance of running directly on the server, but as a virtual machine. Means we can get more out of the CPU memory, means we can be more efficient with power usage, we can get more servers onto a single piece of hardware. This lowers the cost, and then we pass that cost saving on to customers. So that was a whistle-stop tour of some of the custom hardware that we have as part of the infrastructure, and this is growing and innovating all the time. To see this expanding over time and only getting better and better. Really, we've talked about AWS regions so far, and this is going to be appropriate for most use cases. So we're talking about using the out-of-the-box cloud services. When you sign up, you get your AWS account, you pick a region, you provision some resources. That's going to be suitable for most cases, and we'd recommend that anyone does that. But there are some use cases where running your compute in an AWS region is not appropriate. So it might be that customer has super low latency requirements, or they have poor networking. They just cannot connect into an AWS region for whatever reason, or it might be that they have some data residency requirements which require their physical equipment to be on their site. So we appreciate that this is a concern for our customers. We've worked with them for 15 years or so on these kind of challenges. And as a result, we have some additional services which can help solve these challenges. So we have AWS Outposts. I'll show you what this looks like on the next slide. Essentially, it's a rack which you can provision in your own data center and connect it into the AWS region. So you can manage the services in the same way as you can through the normal AWS region console. You can use the same APIs, but the actual infrastructure runs on the rack that you control. You monitor, observe in your own physical location. So you get all the benefits of AWS, but it's on your site. Again, a use case for this might be a media company that needs ultra low latency connectivity, so they're literally sitting next to the rack. This could be a good use case, but they want all the benefits, something that's managed by AWS. We have AWS local zones. So these are an extension of a region. So they provide some services that we offer in the region, but they're essentially metro centers, so they're close to densely populated location. Example of one that we launched recently in Los Angeles. So where there's a demand for some compute resource to run in densely populated areas, but we don't need a full region. We're looking to launch AWS local zones. And AWS Wavelength is looking to take advantage of the 5G network. So where we've customers are using mobile applications connected to cellular networks, a 5G network, they require ultra low latency. Then we have Wavelength, which can essentially provide resources at the service provider's site rather than going over the internet and back to a region. And then over on the right hand side of the screen, we have those where there may not be any network connectivity at all. So we have the AWS Snow family. You may have heard of this. We have a Snowball, a Snowmobile, which is a full 18-wheeler truck, which can hold many terabytes of data. And we also have most recently the Snow Cone, which I'll cover in a minute. We also have some technology for running IoT at the edge as well. So this is an Outpost rack. This is what it looks like. It's a 42U rack, so it's an industry standard. It's fully assembled and ready to be rolled into position. So AWS will turn up at your data center with the rack. We'll plug it in, power it, and connect to network connectivity. And then you'll be able to run some AWS services on your site, but manage them in the same way as running in the cloud. But this is kind of fully managed by AWS, so you wouldn't be responsible for repairing any of the hardware in here, or touching any of the equipment in it. That's all the responsibility still of AWS. So it should be noted that you shouldn't choose to use Outposts unless there's a particular reason to do so, because it is going to be more expensive. This is Snowcone. So this is our newest of the Snow family. The Snow family is around kind of these devices which you can use to do data transfer when you don't have network connectivity. So I mentioned the Snowmobile, which is like an 18-wheeler truck. This can turn up your data center. You can plug it in. You can put all of your data onto it, and then it will drive literally to an AWS region and unload the data rather than sending it across the network. But we've also seen that there's a use case for compute workloads at the edge. So we've released this Snowcone device. It's a rugged device. It's dust tight. It's waterproof. It can fit into a backpack, so it's pretty small. It can be battery operated, and it contains 8 terabytes of usable storage, 2 CPUs, and 4 gig of RAM. So the idea here is that you could plug it into somewhere where There may be intermittent networking. It might be a small space or a difficult location, like thinking about like an oil rig in the middle of the ocean. It could be used in a backpack for a first responder. It could be used on transportation, a lorry or a train or something like this, or even carried by a drone. Um, but you can actually run some EC2 instances on this device, as well as using it as like a storage transfer solution. So you could keep it permanently at the site and actually run some compute there. It operates like in harsh conditions as well, so from freezing to desert-like conditions. So really, really rugged. You could literally put it anywhere you like, and run some EC2 compute workloads. So this gives you an extension of AWS where you can't necessarily take advantage of the cloud regions as they come. And then finally, I just wanted to cover a little bit on sustainability. So 10 years ago, Uh, Amazon founded the Climate Pledge, so this is effectively a pledge to meet the Paris Agreement 10 years early to be net zero carbon or net carbon zero by 2040. And we have a path to be 100% renewable energy by 2025. Um, Amazon is the world's largest purchaser of renewable energy. As I said, we have a path to be 100% renewable energy by 2025 for all of our data centers, and we have a number of projects for utility scale solar and wind farm, trying to get as much renewable energy to power our data centers as possible. And a study from 2019 showed that running in AWS is actually 3.5 times more energy efficient than using like an enterprise class data center. This is because we operate at such a scale. We have a lot of experience in operating data centers. We can run things very much more efficiently than if you were to run them yourselves. So actually running in the cloud is considered more energy efficient than running on premise. Um, so yeah, the study found that you could perform the same task with AWS at 88% lower carbon footprint. And this was from 2019, and since then we've had additional launches such as Graviton 2, which I mentioned earlier, which reduces the energy efficiency further, provides you more performance for a smaller amount of power. So we can see this saving, only growing over time. So a lot of customers can save on their carbon footprint by actually using the cloud as well. And that's it. So that's all I have to say. That was just an introduction to the global footprint, how we operate our regions, a little bit of AWS hardware and some of that hybrid connectivity and IoT devices. So yeah, happy to take any questions from anyone. Could you please explain again about AWS Wavelength? Yes, so Wavelength is a fairly new service, so it's taking advantage of the 5G network, which is being rolled out globally. And we work with service providers, people like AT&T, Vodafone, to provide will provide the ability to run some services which are connected to that cellular network. So rather than if you're using a mobile device, rather than that device connecting to the internet, going to a region, it would connect to something that was much closer to it networking wise, and therefore we can provide lower latency. Yeah, no problem, Wendy. Yeah, any other questions? I don't necessarily have to be about global infrastructure. If you had any other questions around AWS or my job or career, then that's absolutely fine as well. We've got sort of 10 minutes or so. What's my cat's name? My cat's name is Hendrik. He's a lilac tabby British short hair cat. Um, if you Google the British short hair, they've got very chubby faces. They if you've ever seen Alice in Wonderland, the grinning Cheshire cat is modelled on the British short hair. Mhm. Can you talk a bit more about containers, please? Sure. So um, I can talk about what containers are, or I can talk about how they're used at AWS. What would you like to know? Yeah, so at AWS, we have a number of services that can support container workloads. Um, Docker is obviously the most common tool set used to build containers. So those of you that don't know what a container is, it's essentially a package of software which you wrap up and run on top of a server. So it makes your application more portable and protects it from having kind of dependency mismatch. Um, and we have a couple of services in AWS. One is called the Elastic Container Service, or ECS. This is our cloud, or kind of our AWS developed container technology. So it's most integrated with our AWS services. And we also have one called EKS, which is Elastic Kubernetes Service. So have you ever heard of Kubernetes? This is a container orchestrator, which is open source. Lots of people use it outside of AWS. But EKS, or Kubernetes Service, can help you run Kubernetes workloads on AWS without having the headache of actually provisioning the management plane. So we actually provision all the servers required to have that management plane, allowing you to kind of run the container workload without having to manage that part of it. We also have a service called Fargate as well. So if you've ever heard of Fargate on AWS, this is our serverless container offering. Now, by serverless, we mean that, of course, there are servers underneath that are running, but the servers are managed by AWS. So we have ECS Fargate and EKS Fargate. Both can be used to run containers. So hopefully that helps. We did actually launch a service only a few weeks back called App Runner. So if you're building a web application and it's kind of really straightforward web application, you don't really care about how the container runs. You've just got a container and you want it to work. App Runner is a good service for you. So you just give it the source code. It will build your container. It will set up the pipelines. It will set up the load balancer for you, and your application will be hosted, kind of mostly managed by AWS. How about Elastic Compute Registry? Yeah, so ECR fits into the equation as a container repository. So if you've ever used Docker Hub is a container repository. This is somewhere where you pull a container from. So if you want an Nginx container that's on Docker Hub, you can do Docker pull Nginx, and it will pull from Docker Hub. But if you want your own private repository, then you can use ECR, or Elastic Container Registry. So you can set up Elastic Container Registry fairly easily in AWS. You can upload or push your containers to that registry, and then when you use ECS or EKS, you can pull them from that registry. I guess we'll have to know AWS services on the fly like you, Tom. Yeah, so I think that I'm a solution architect and I'm a generalist solution architect. So my job is to have like a broad understanding across most of the AWS services, but we do have 200 plus services. So this is an impossible task to understand them all. So a lot of it is actually, saying when you don't know. A lot of customers ask me questions every day, and I just don't know the answer. So I just tell them that I don't know the answer. But what I can do is find out. There's always people that are willing to help. There's always people who are more knowledgeable. So as long as you go to the right person and ask the right question, that's the best way to help the customer. If I tried to lie to them and make it up on the spot, they'd realize quite quickly. But yeah, it is there is a lot to learn, and it can be quite overwhelming. But as I work for AWS and this is my job, I speak to customers every day. I am very immersed in the technology, so have a fairly good understanding. But if you're starting out in your tech careers and AWS, then that can be quite daunting. So my advice would be just to take it as it comes. Don't try and learn everything. Don't try and understand everything. Try and think about a particular problem that you want to solve, and practically have a go at solving that. So anything that you work out and solve and implement on your own will stick with you much more than if you sit through and try and learn everything.
About the solution architecture career. Okay. My question is it only related to customers directly? I mean, or or is there like an alternative way of using that architecture? Only you only deal with clients. I mean, that's my question.
Yeah, so at AWS as a solution architect, I only deal with customers. But if you're a solution architect for a company, then you're generally building and designing solutions for them, right? So you're building their own products, whereas I'm helping other customers solve problems. We do also have at AWS specialist solution architects. So these are people who specialize in one particular domain. So it might be machine learning, it might be analytics, it might be storage. Those people are kind of more focused. They will spend slightly less time with customers and more time thinking about content that they might publish or ways to help the internal community. But the solution architect role in general, if you work directly for a company, then obviously you're going to be more responsible for delivering projects for that company rather than talking with external customers. Before this role, I was an engineer, so I worked as a DevOps engineer, um, basically implementing things like CI/CD pipelines, managing infrastructure for other companies. How does one get to start out as a solution architect? Um, I think that I'm not sure if it's like a role that you can just jump straight into. So I think you probably need to just establish some technical experience first. So going in as like an infrastructure analyst or an infrastructure engineer, um, just to get some hands-on experience, or a developer, software developer, something like that. Just to get some real hands-on experience on how things work and what kind of challenges there are. But there's lots of training as well out there. If you're specifically interested in the cloud, like working towards a solution architect associate qualification is a good way to start. So this will give you like a general understanding of how services fit together and how you might architect those. Would you suggest going down the DevOps role before becoming SA? Yeah. So again, I think it does depend, but I'd say if you're starting out in a tech career, then you're going to start out in more of a junior role, and I recommend getting some hands-on experience in like an engineer type role, something like a developer. But that's not to say that you can't go straight to an SA role. We do, for example, have a program at AWS where we recruit people who come straight out of university. So we kind of put them on the solution architect path straight out of university, and that exists in other companies as well.
Hello, sorry. I have a question. Um, I do have experience in software development, but I'm not sure which one is better for me. Is it solutions architecture or it's development? association, which one is better? Because when I read responsibilities or duties, looks like solutions as this HR is more like programming. I don't know if I understand it right.
You mean in terms of which certification to take?
Yes, yeah.
Yeah, so if you're a software developer right now, then I think the developer associate exam would be a good starting place. The free associate exams, there's this solution architect associate, developer associate, and then the sysops administrator. The free exams are sort of quite similar actually. There's a lot of content which crosses over between them. But then they're tailored towards that particular role. So for yourself as a developer, then the developer one makes more sense because a lot of the topics are more tailored to writing code and the kind of problems that you'll face in writing code, like API errors, dealing with exponential back office and stuff like that. Whereas system administrator would be things like an operational level, looking at CloudWatch alerts. But I'd also say if you want a good general knowledge of AWS, then the solution architect associate one is a good one to do. So it's up to you. I'd suggest having a look at the sample questions on the certification site. That'll give you an idea of the kind of topics that cover in each of those exams.
Okay, thank you.
Do you feel bored without seeing anybody? I mean, without a camera. I mean, you are just talking to people who have no camera and they don't talk. I mean, yeah, a funny question.
No, not at all. Absolutely fine. I'm happy as long as you can see me. I'm happy. Yeah, it's interesting in this virtual world. Some people prefer to go on camera, some people don't, and think it's fine either way. Okay, I think we've come up to time then. So I've reached the end of my slot, but thank you all very much for listening. I hope it was interesting. Yeah, and good luck with your career journeys.
All right. Thank you very much, Tom. You've been brilliant, and the webinar has been very informative and interesting. So thank you very much. Peace be with you.
No problem. Thank you very much. All have a great day.
Nice. You too.
Thanks,
Last
Thomas.
thing,
Thanks, everyone.
could we connect to you at LinkedIn, for example? Is it?
Yeah, sure. Yeah, you can search
Okay,
me on
nice.
LinkedIn.
Okay.
Thomas Moore AWS. You can search.
Okay.
No problem. Right. Have a great day, everyone. Thanks so much. And yeah,
Right.
good luck on
Enjoy
your
the webinar.
journeys. Keep learning cloud.
Thank you.
Bye.
Bye.
Thanks. Bye-bye.